Hello there, Mr. Sutton here, bringing you the Pre-Cal Honors 2-6 Part 2 homework solutions on writing polynomial functions. To find the specific equation for this polynomial, we're going to write kind of a general possible equation with a mystery constant a out in front, and then we'll solve for a. So to start this off with, let's look at the overall sign of the polynomial. Since I'm moving up as I move to the right, that means this is going to be a positive function. So I'm going to write y equals positive a, just to start things off here. And then for the individual factors, so we're hitting 0 here, so that means we have a factor of x minus 0, or just x. But since we're bouncing off of 0, that's actually a double root, so we have to write x squared for that. And then we're crossing straight through 2, so that means it's a single root at 2, so we're going to have a factor of x minus 2 just to the first power for that one. So this is a possible equation, but we need to find the value of a. To do so, we will plug in the point -1 comma -6, because that is on the polynomial. So y is going to be -6, and I'll substitute -1 for all the x's. So I have a times -1 squared times -1 minus 2. Simplifying things on the right side, well, -1 squared is just positive 1, so I can ignore that if I'm multiplying by it. -1 minus 2 is -3, so this is -3a on the right side. Dividing by -3 to get a by itself, we see that a equals 2. And don't forget to plug this back in. So plugging in 2 up here, we can write y equals 2x squared, parentheses x minus 2. Before we write a specific equation on this problem, let's first write a general kind of equation for this polynomial, using just the overall shape and the x-intercepts. So for the sign of this, and I'm just going to put a mystery constant a out in front because I don't know what the constant out in front is supposed to be yet. But for the overall sign of this, we're ending up, so that means we have a positive a value out in front. So y equals just a, positive a. But now I have to write all the factors with the x's in them. So going from left to right, on the left we have this -1 root. Now since we're flattening through that, this is a triple root. So that tells me I'm going to have an x plus 1 cubed as that factor, x plus 1 cubed. And now over on the right side, since we're just crossing straight through 2 without flattening or bouncing, this is a single root, so we have x minus 2 for that one. Now I have to find the value of a. So for that, I will plug in the point that they gave me, this 0 comma -4. So I've got -4 for y, and I'm going to plug in 0 for all the x's. So we have a times, and then this is going to be 0 plus 1 cubed, and 0 minus 2. Simplifying a bit, well, this is really just 1 cubed, which is just positive 1. A times 1 is still just a. For this other parentheses, we have -2. So overall, that's -2a that I have on the right side. And then dividing both sides by -2, we see that a equals positive 2. Plugging that back into this general equation we wrote in the beginning, we can write y equals 2, parentheses x plus 1 cubed, and then x minus 2. To find the specific equation for this polynomial, let's begin with kind of a general equation, and I'll put a mystery constant of a in there because I don't know what it is yet. So for the overall sign of this polynomial, we're going down as we go to the far right, so that's negative polynomial overall. So I'll write y equals -a to start, and now I need the x's and the factors and all that. So my first 0 on the left side here is this -1, so that's a factor of x plus 1. But now since we're bouncing here, that's going to be a double root at -1, so that means I need to write x plus 1 quantity squared, this 2 here to reflect the double root. Now we also have 1 as a 0, and we're just crossing straight through, so that's a single root. So I write just x minus 1 first power for that one. I don't have to write the 1 up there. And then we're crossing straight through 2 as well, so that's also a single root. So I'm just going to write x minus 2 for that factor. Now to find the a value, I need to plug in the point that they gave me here, 0 comma -3. So we have -3 for y and 0 for all these x's here. So that's -a times 0 plus 1 squared times 0 minus 1 times 0 minus 2. Well, 0 plus 1 is just 1. Squaring that doesn't change the fact. So that's pretty much not going to make a difference if you're multiplying by 1. Here we have a -1 times a -2, so that's a positive 2. But that's getting multiplied by this -a that was already there. So overall, that's a -2 2a. And then dividing to get a by itself, we can write a equals positive 3/2. So that's my a value. Just plugging that back in here to get an actual equation, we have y equals negative 3/2 times x plus 1 squared, x minus 1, x minus 2. On this problem, I want the specific equation for this polynomial that goes through this point here. Let me start with a general equation, and I'll put an a in there just because I don't know what it is yet, but that'll be my constant out in front. So let's see here. Let's start with the sign of this polynomial. Since we're going down as we move to the right, this is a negative polynomial, so I can at least write y equals negative a. And now we also have to get the factors with x's. I'm going to start with this 0 here. I always like to start if I have the origin as one of my zeros. So that means we have x minus 0 as one of our factors. Actually, we can just write x. But since we're bouncing there, that's a double root at 0. So that means I have to write x squared because it's a double root. Now I also have a factor for this negative 3, 0. I have a factor of x plus 3. Since we're crossing straight through negative 3 without bouncing or flattening, that means that it's just going to be x plus 3 to the first power. That's a single root at negative 3. And now I have enough to solve for a. Let me plug in my point that they gave me, negative 1 comma negative 4 for x and y. So for my y value, I've got negative 4. For the x values, I've got this negative 1 that they gave me. So I can write negative a times negative 1 squared times negative 1 plus 3. Negative 1 squared is just positive 1, so that's not going to make a difference if we multiply by it. Negative 1 plus 3, that's 2. We already have a negative a, so that's negative 2a out on the right side there. And then dividing by negative 2 to get my a value, that's going to be a equals positive 2, which is a nice round number. Plugging that back in to get an actual function, a specific function, we can write y equals negative 2x squared parentheses x plus 3. To figure out the specific equation for this polynomial, I'll start with a general equation that has kind of a mystery a value out in front. Let me get the sign of my polynomial to start with. Since we're moving up as we go to the right, this is positive, so I'm going to write y equals positive a. And now for the x's and factors and all that, going from left to right, we're hitting negative 5 as our first 0, so that's a factor of x plus 5. Now since we're crossing rather than bouncing or flattening there, that's a single root. So this is x plus 5 to the first power. Next, let's get this factor for negative 1. Since we're bouncing there, that is a double root, so I have to write x plus 1 squared. And then finally, for the 2 that we're just crossing straight through, that's going to be an x minus 2. Now I have to find the value of a. To do that, I'm going to plug in the point 0 comma negative 8 that they gave me. So that's negative 8 for the y value, and this is going to be 0 for all the x values. So a times 0 plus 5, 0 plus 1 squared, and 0 minus 2. So let's see, we've got a 5. This is just 1, which doesn't really make a difference if you're multiplying. So we still have a 5 times a negative 2 over here. That's negative 10. So when the dust settles, we have negative 10a on the right side. Dividing by negative 10, 8 over 10, we can reduce that to 4/5. So that's our a value. And then we're just going to go back and plug that in to the original that we wrote up here. So we can say y equals 4/5 times x plus 5, x plus 1 squared, and x minus 2. To get the specific equation for this polynomial, I need to start with a general equation, and I'll put an a out in front because I don't really know what that mystery constant should be yet. So for the overall sign of my polynomial, we're going down as we go to the right. So this is negative, so I'll write y equals negative a. And then for the rest of it, let me get my factors with x's. So the first 0 that I have is this negative 7. That means I have x plus 7 as a factor. And since I'm crossing straight through instead of bouncing or flattening like we are over here, this is a single root, so it's just x plus 7, all of that to the first power, which I don't have to write the exponent for. Now we also have this 0 at 4, so that's x minus 4 for the factor. Since we're flattening, that is a triple root at 4. So that means I have to write x minus 4 quantity cubed. And now I need to find the a value. To do that, I'm going to plug in the point 3 comma 2 that they said was on the graph here. So we have 2 for the y value, 3 for all the x values. So that's negative a times 3 plus 7 times 3 minus 4 cubed. 3 plus 7 is 10. 3 minus 4 is negative 1. Cubing that keeps it negative 1. So we have 10 times negative 1, which is negative 10, times the negative a that was already there, though. That's going to be just positive 10a. So to solve for a, we just divide by 10. 2 over 10, I can reduce that to 1/5. So my a value is 1/5. And plugging that back in up here, we can now write y equals negative 1/5, x plus 7, x minus 4 cubed.